for it to fit the binomial process, there are 4 characteristics that have to be met, okay? Or each of these 4 things has to be satisfied. Okay, so first of all, the experiment consists of n independent trials. So what that means is that the experiment, they'll tell you, consists of like 10 independent trials or 20 independent trials. Okay, but it has to be a set number. The second, each trial results in a success or a failure. So when you're completing the trial, it's either yes or no. Okay, success or failure. It can't be a range of values. So an example, if I take a dice and I throw it down, what are all my options on a dice?
6.
1, 2, 3, 4, 5, 6, right? That's not a success or a failure because that's 6 different choices. So you can only have 2 different options. It's either a success or a failure. The probability of success, P of S, or P, is the same in each and every trial. So that probability of success doesn't change. It stays constant from trial to trial. The probability of failure, P of F or Q, is 1 minus P because notice they have to both add up to be 1. And then the trials are independent. So let's go ahead and look at, oops, hit the wrong thing, there we go. We're going to determine whether each experiment is a binomial experiment or it can be reduced to a binomial experiment. If it can be binomial, state the values of n, p, and q, then list all possible values of the random variable. So 5 cards are drawn at random from a deck. The random variable represents the number of spades. So I draw 1 card. Is it a spade? Yes or no? Okay. So I draw another card. So basically I draw 5 cards. So first of all, let's go through the checklist. How many trials are there? 5, because there's 5 cards, right? So now the next one, if you remember, it says each trial has 2 possible outcomes, success or failure. So success is what? Spade. Failure is not a spade. So far that fits as well. The next one, the probability of success is the same from trial to trial. Is that true? No, why not?
Because if you draw a spade, that
Yeah. If you draw a spade, you take 1 out of the mix, and so the probability that you're going to get a spade on the next draw is not going to be the same. So as a result, this is not binomial. Okay, so this one is not binomial. Reason being, the probability of success does not stay constant from trial to trial. Now, if it would have said drawn with replacement where you put the card back in, then yeah. But this one it didn't. So let's go and look at another one. You complete a test by randomly guessing the answers to 20 multiple choice questions that each have 4 answer choices, only one of which is correct. The random variable represents the number of correct answers. So first of all, how many trials? 20. Does each trial result in a success or a failure?
Yes.
Yep, because it's right or wrong. Does the probability of success stay the same from problem to problem?
Yes.
Yeah, what's the probability that you're going to get it right? 1 out of 4. Okay, and then the final one, all the trials are independent. So by independent, they mean when you go to question 2, it doesn't pertain to question 1. Okay, and they are all independent. So this, in fact, is binomial. So what we're going to identify is we're going to identify N, P, and Q. So N, somebody tell me what N is? 20. Yep, N is the number of trials. Good. So there are 20 different trials. Okay, P is my probability of success. What's my probability of success? 1/4, but I'm going to write that as 0.25. Does anybody know what Q is then? 0.75, yeah, 3/4. Okay, and so what it says now is it says to, now we want to give all the different answers. And so the different answers on this one are either going to be correct or incorrect. Okay, so in this case, I can get 0 correct, 1 correct, 2 correct, 3 correct, all the way up until 20. So that's the values of the random variable. So when you do this on your homework, you have to identify if it's binomial. If it's binomial, I need to know n, p, and q, and then I need to know the values of the random variable. So basically, in this case, it's the number of correct answers. Think you can handle that? Okay. Now what we're going to do is we're going to talk about actually how you find the probability. Okay, so this is the binomial probability formula. Okay, the binomial probability formula. And so P of x equals n choose x. P to the x and then q to the n minus x. Now n, p, and q are the problems we just got done finding. Are the answers we just got done finding in the problem before. Biggest thing that we haven't talked about yet is what x is. X is the number of successes. So there you go. All right, so are we good to go? Let's go ahead and look at an example then. In a certain high school graduating class, 48% of the students took a world language during their senior year. 7 students chosen at random are asked if they took a world language during their final year. Construct and graph a probability distribution for the random variable x, which represents the number of students who said yes. Then find the probability that fewer than 4 of these students said yes. So now what we're going to do is we're just going to go ahead and start. We're going to start by finding each of the values. And so we're going to find the value that 0 students that took a random. 1, 2, 3, 4, 5, 6, 7. So we're going to do this 7 times. Okay. So the first one, what we're going to do is we're going to do 7 choose 0. So of those 7 students, none of those 7 took a world language. Probability they took a world language is what? 0.48. Okay, so I'm going to take 0.48 to the 0 power. So whatever those numbers are, they match. What's the probability they didn't take a world language? 0.52. Kicker here is that these 2 exponents have to add up to 7. Okay, so whatever your total number is, those 2 add up to 7. So my next one will be 7 choose 1. Okay, 0.48 to the first, 0.52 to the what? 6. So you get the hang of things?
Yeah.
What's the next one going to be? 7 choose 2. 0.48 squared, 0.52 to the 5th. Okay, so then now what we're going to do is we're going to divide this and conquer. So Zach, your group is going to be responsible for 0, 1, and 2. You guys are responsible for 3, 4, and 5. You guys are responsible for 6 and 7. Okay, just a second. Okay, so do we have an answer? You need to ask Mrs. Yep. I need him back for me.
How far do you want to
Okay, what?
How far do you want?
4.
Alright, so 0.0103.
Okay, what's the next one? 1993. Next one. Do you got 3 yet? 0.28 what?
7 is 0.0059. 4 is 2612.
Okay.
6 is 0.04.
Yeah. What'd you get?
I'm not sure.
Point 184.
Okay, so now the question is, should it go from biggest to small? In fact, no, because the probability is only 48%. So the highest probability is going to be 48% of 7, which is about 3.36. So your highest probability is going to be right in here. And it's going to be closer to 3 as opposed to 4 because the 0.48 of 7 is 3.36 students. And so gradually then it's going to work its way out based on that. What do you know about all these probabilities if you were to add them up? They would equal 1. Okay, now obviously since we've rounded, they're not going to be perfectly 1. It's probably going to be pretty close. And so if we look at the what it says construct and graph. You know what? This will go fine for me. Your book actually goes through where it graphs them on a bar graph, and it starts with 0, and then it goes to 1, and then what it does is it graphs them like this. Okay, the reason why we're not going to do that is because I'm not going to have you graph those tiny decimals. Okay, so the next one it says to find the probability that fewer than 4 of these students said yes. So fewer than 4. Fewer than 4 means what? I know, but so like what numbers? 0, 1, 2, and 3. So here we go, 0, 1, 2, and 3. So this is the probability. So what do you think I need to do with those numbers?
Add them up.
Add them up. Okay?
That's what I do. So like 5, 6.4.
Okay, whoa, you need to go back and look at number 1 real quick. We got an issue. Where's there an issue here? Somebody tell me where there's
Whoa,
a problem.
that's bigger than number 2.
Exactly. We got to redo this one right here.
That comes in.
Okay, let's rework that one real quick.
Come on, man.
Because that one's...
Dylan. We all know 7 choose 1 is 1.
So.
There we go. Try adding those now. Try adding those now and see what we get.
I was actually honestly going to say earlier, I did not
So what's the probability? Hello?
That's faster. 5437.
0.5437, so the probability would actually be 54.37% that of those 7, less than 4 or fewer than 4 took a world language class their senior year. Okay. Now, if you wanted more than 4, you would just add up the 5, 6, and 7. So based on the question they ask you, you can go ahead and answer that. Let's go ahead and look at another one. Okay. Okay. Mean and standard deviation of a binomial distribution. The mean, variance, and standard deviation of a random variable are given as follows. So I need you to go ahead and write those down. Okay, go ahead and write those down. The mean equals n times p, the variance equals n times p times q, and the standard deviation equals the square root of the variance or the square root of n p q.
Because it's Greek. Most of our words are from Greek.
Okay. So we're going to go ahead and look at an example here.
Alright.
Okay, now notice what it says. The table shows the binomial distribution in example 7. Find the mean, variance, and standard deviation of the distribution. Okay, interpret the mean in the context of the situation. So, if you go ahead and look at, on example 7, page 669, we know that the mean is equal to n times p. What is n in this problem? Yeah, so how many trials do I have? 5. Okay, how do I know I look at this number? What is the probability of success? So the probability of success, if you look at page 669, what's the probability of success in the problem? What's the probability of success?
35%?
Yep, 0.35. So let's take 5 times 0.35 and what do you get? 1.75, there's the mean. Okay, there is another way to find the mean, and remember we learned about that, and that's by taking x times p of x and then adding all those values up. But notice this is a lot easier. Okay, so we don't have to worry about that. Now what we need to do is find the variance. So the variance, if you remember, the variance is equal to this n times p times q from that. So now all I need to do is plug in what I know. I know that n is what? 5. I know that p is what? 0.35. I know that q is what? 6.5 because it's 1 minus that. And so then if I take 5 times 0.35 times 0.65, what do I get the variance to be? 1.1375. And so last but not least I need to find is the standard deviation. So the standard deviation is nothing more than the square root of the answer right above, 1.1375. And so if I take the square root of that, what do you get? 1.0665. So there you go. So that is the standard deviation. The u is the mean. That's the variance, and then the standard deviation. Because that's from the original problem in example 7. So what you need to do now is on pages 671 and 672, I need you to add 13 through 24. 13 through 24 all, add that. Okay, probably going to have a quiz tomorrow.